chapter 19 is toxicology. Okay, basically toxicology is we're talking about poisons. Okay, poisons are compounds whose main effect is toxic to humans. Now, if you remember back last chapter, anything can be a poison. It just all depends on the dosage. If we can learn to control the dosage, we can make a poison not so poisonous and maybe actually use it for good. So some have beneficial effects if used in small doses. So like for instance, botulinum, the first one I can't pronounce, on the very first slide. Basically, this is a muscle relaxant, which is not showing up there for some reason. It's not showing up, but basically, if you're under the effects of this in your diaphragm or your heart, it's very bad, because if it relaxes those muscles too much, your heart's going to stop beating, and you're going to stop. Your diaphragm actually controls your oxygen regulation in your body, and so that would be bad. However, we also use the same poison through Botox, which actually, it's not just, of course, you can insert it into facial muscles to get rid of wrinkles, but there's actually other, they actually use it for cerebral palsy and Parkinson's disease. Because Parkinson's disease is where your muscles, you can't really control them anymore, and so they're always moving and they're constantly shaking. And so basically this will calm down the muscles, and so it gives them relief of the symptoms for a while. And so it's not just superficial. There's actually good uses for Botox. So one type of poison are corrosive poisons, and basically these poisons, they don't target anything in specific. They basically, any cell they come into contact with, they destroy. And so these are the very, very bad types of poison. So these types of poisons are your strong acids or your strong bases or your strong oxidizers. So some examples of these are HCl, which is hydrochloric acid. This is often used for people who have pools. It is used to maintain pH in pools. Sulfuric acid, which is H2SO4. This is battery acid. And so battery acid we use in batteries. There's also sodium hydroxide, which is soda lye, we talked about that a lot when we were making soap. This is used a lot in detergents and soaps around your house. And then we have NaOCl, which is bleach. Bleach is actually a really strong oxidizer. And so, honestly, your skin can provide as a really good barrier for any of these chemicals, as long as it is a brief contact. Like if you get bleach on your skin, not the end of the world. Especially the bleach around your house, because the bleach at your house is diluted so much with water. But at the same time, if you leave it there for very long, your skin will start to turn red and maybe feel a little bit irritated. But then you just wash it away and you're good to go. However, if you ingest any of these, that's when we start to have some of the problems, is because, like I said, they don't target specific cells. One cell, as soon as they come into contact with cells, they start causing damage. So they start to affect your esophagus, your stomach. Once it gets into your stomach, it starts to be absorbed throughout your body. And so there's lots of other issues. And so if you ingest it internally, oftentimes, you need to get your stomach pumped a lot of times. You could induce vomiting, try to get it out of your system as quick as possible. But if it's a very strong acid or base, if it messes with your esophagus going down, it's going to do the same thing coming back up, and so it might actually cause your esophagus to have a hole or a tear in it and then get into your system even farther. The best thing that you can do is actually dilute it. So if you actually ingest one of those things that are commonly found around your house, just drink lots and lots of water. If you can dilute an acid, it's not going to be as harmful as if it was in a strong form. And then you could also neutralize it, which would just require you to have a little bit of knowledge of what things are around your house. So like for instance, if you ingest an acid, so if you ingest like the pool cleaner, or if maybe your kids ingest it, or bleach or anything like that, if you ingest something that is acidic, neutralize it with a base. Okay, if you ingest something base, neutralize it with an acid. Now, I don't recommend drinking strong acids or bases to try to neutralize something you accidentally ingested. But you don't need strong acids or bases. You can use weak acids or bases. They will do the job just as well. So like for instance, if one of your kids accidentally ingests some of the pool cleaner, okay, have them eat some baking soda, drink some milk of magnesia. You have this lying around your house. They're basic. They're not strong bases. They're not going to hurt you. You take milk of magnesia to work for acid reflux, right? And so they're not going to hurt, but at the same time, they'll start to neutralize that acid in their stomach, and so you won't get some of the harmful effects. If you accidentally ingest something basic, vinegar is acidic, lemon juice is acidic. Most of you have these in your pantries at your house, so they will do the same thing, but at the same time, they're not going to hurt you because they're pretty weak. If you get an oxidizing agent like bleach, bleach is really, really, really bad. If you ingest bleach, all you can do is really dilute it and go to the hospital. I mean, there's really nothing that can counteract the effects of bleach. Bleach is very, very damaging, which is why it works so well to in your clothes, because it destroys basically everything. If you're not sure if it's an acid or a base, you could use something called a universal antidote. You can find it in pharmacies. You can buy it, something that you drink. Or if you're at home and you can't eat something, you're not really sure, your dog or something eats something, you're trying to figure out what to do. I mean, just eat some toast. Toast is it absorbs very well. It's carbon, and so it's going to neutralize some of those acids and bases. Drink some really strong tea because that's acidic. Drink some milk of magnesia because that's basic. So basically, if we eat a combination of this, hopefully it will do what it's supposed to do, whether it's supposed to neutralize an acid or neutralize a base. And then, of course, if you drink milk or egg white, it coats your stomach, and so it'll slow down your body's absorption of the acids or the bases. Okay, so the next type of poisons we're going to talk about are blood agents. These are compounds that interfere with oxygen transport or utilization. So can your body absorb oxygen? Can it use the oxygen properly? And so there are 4 different types of blood agents that we're going to talk about. There's carbon monoxide, nitrates, hydrogen cyanide, and heavy metals, which we talked about heavy metals in the last couple of units. Okay, so first of all, we have carbon monoxide, which is CO. Basically, it's really toxic because it ties up your hemoglobin. So this is, a lot of times your furnaces or some other appliances in your house will accidentally give off carbon monoxide. And so that's why you have carbon monoxide, because it's a silent killer. You don't know it's there. And as you breathe it in, it basically occupies your hemoglobin. And if your hemoglobin can no longer transport oxygen, you start to get lightheaded, and eventually it'll cause you to pass out. And if you continue to breathe in the carbon monoxide, eventually it's going to, your brain's not going to have any more oxygen, and so it can actually kill you, which is how people die by carbon monoxide. Because it starves your cells for oxygen. Your cells don't have oxygen, then they die. And so another bad thing about carbon monoxide is once it gets into your system, once it gets into your hemoglobin, it doesn't let go. And so if you're breathing in more carbon monoxide than your body can make hemoglobin, then that's a recipe for disaster. Which is why if you have carbon monoxide poisoning and you get out of the room with carbon monoxide, you're going to be fine because your body can start to repair them. The next one is nitrates, which is also can be turned into nitrites. Nitrate is NO3, nitrite is NO2, so basically the only difference between the two is in oxygen. Nitrates are often found in fertilizers, which we've already talked about how those can get into the waterways, right? Fertilizers are put onto the ground, then with runoff they're ran off into the waterways or the groundwater, and there's lots of various ways they can end up in your water supply in your house. But basically, they do a very similar thing to carbon monoxide. Nitrates are converted into nitrites in your body. The nitrates then also bind to the hemoglobin, which reduces its ability to transfer oxygen. This is really, really bad in little kids because little kids, their hemoglobin is not quite the same as ours, especially until 6 months, their hemoglobin is just a little bit different. That doesn't work in quite the same way. And so if they're under nitrates, it's actually called blue baby syndrome, and the baby will actually start to look kind of blue because it's suffocating. It's not getting enough oxygen to its brain, and so it's actually kind of starting to suffocate it. And this isn't a big issue in cities because we have wastewater treatment plants, but if you have well water or honestly, I can only think of well water. If you have well water and you live in an agricultural area, then this is when it becomes an issue. Another thing that can affect your blood is the hydrogen cyanide, which is HCN. This compound is used to execute people into the gas chamber. So basically what happens is we can react sodium cyanide or potassium cyanide with a really strong acid. And in the process, it will produce hydrogen cyanide. And what it does is it works in the same way as the other two, is it affects your body's ability to use oxygen, but it doesn't really affect your hemoglobin. It affects an enzyme in your cells called the cytochromes, and basically these are the ones that utilize the oxygen. So if the if your enzymes are no longer being able to utilize the oxygen, then it causes the cells to start to die. Because yes, the oxygen's there, but the cell can't use the oxygen because the mechanism that is there to use the oxygen is being tied up by this other thing. And so basically it causes your cells to die. Now the good thing about this one is there is an antidote. There's actually several, but one of them is sodium thiosulfate. If you are in a gas chamber or you know you've been exposed to hydrogen cyanide, they can give you this and it basically unties up your enzymes. It causes the hydrogen cyanide to stick to it as opposed to your cells, and so it changes the bonding. So the next or the last one is your heavy metals, which we've talked about a lot. Basically, heavy metals, they are cumulative poisons, which means if you get a little bit of mercury, you're fine. If you get a little bit of mercury every single day for a year, not so much, because your body can't get rid of it. And so it starts to accumulate in your system, and then eventually it will reach toxic levels, which is when it causes harm. Now, there are two types of ways that you can be poisoned by this. Acute is when you are exposed to a high enough amount that it causes the immediate symptoms. Okay? Chronic is when you are exposed to a small amount over time, and the bad part about it is you don't see any symptoms, you don't feel any symptoms until the level is so high that it's toxic. And this is the one that is much harder to treat. So this would be like, we talked about the water system, the World Health Organization made the wells, and what they noticed over 20 years is that they started having cases of arsenic poisoning. Well, it took 20 years for us to realize that because the levels were so small that they didn't notice it at first. But then as it started to build up in people's systems, they started then realizing it was arsenic poisoning. This is also how you can poison people with arsenic, right? And they can add it to their food, but it's a really, really slow and painful disease, or death, I guess you would say, because first of all, you don't know what it is because it mimics so many other diseases, and you don't really have true symptoms until the levels are so bad that there's really nothing they can do about it, or it's hard to fix it. So some of these heavy metals that are cumulative poisons are lead. Lead can actually cause brain damage, and it is or was used in paint, pottery glaze, pipes back before we had copper and plastic, or before we could manufacture it into the ways that we use them now. And then, of course, we used to have leaded gas back before we had catalytic converters. Now, a lot of things are not made with lead just because a lot of the things that used to have lead in them were around things that you would eat, and so it was really easy for people to ingest lead, and so now we know a little bit better. People actually used to, the Greeks actually used to put it in their wine to make their wine taste sweeter, but they didn't know about lead poisoning them. Another one is mercury. This also causes brain damage, and it is often found in thermometers, thermostats, batteries, not so much now. But if you have an old home with an old thermostat, it's probably going to have mercury in it. I mean, thermometers, you could probably still buy mercury thermometers if you really wanted to. But the last 10, 15 years, they haven't been making them quite as much. Honestly, the majority of mercury poisoning comes from the burning of coal. Mercury is often found along with coal in the ground. So as we burn coal, we burn the compounds that contain mercury. Well, mercury is liquid at room temperature. And so as we burn it and it starts to separate, it can actually run into the waters really easily because it's liquid at room temperature. It's not solid at room temperature like other metals. And so then it enters the waterways, and then fish start to eat it, and then it starts to work its way up the food chain. And so that's why you're not supposed to eat a lot of tuna or swordfish, because they can have high levels of mercury in them. So if you eat tuna often, it can build up your levels of mercury in your body. If you eat tuna occasionally, it's fine, but you shouldn't eat it every day for months on end. Another heavy metal is arsenic. This actually interacts with the proteins in your body, and it causes them to not work properly. If the proteins in your body are not working properly, your cells lose all their structure. And so if your cells don't have the correct structure, then you start to become really weak. Your systems start to become damaged, and your cells aren't working properly. And so this is actually what we use in rat poisons. And it's actually, a long time ago, it was actually called inheritance powder, is because people would actually feed it to their relatives when they wanted them to die so they could get all of their inheritance. I don't know if that's true or not, but I could see it back in like the 1700s in the royalty when they're trying to control who's in power of certain monarchs. I could see that happening. When we're talking about heavy metals, we actually also need to talk about something called a chelating agent. Basically, these can be used to trap heavy metals before they get into your cells. So if you know that you've been exposed to arsenic, if you know that you've been exposed to mercury, is it a death sentence? No. If we catch it early enough, we can do something about it. And so we can use different forms of chelating agents, and basically what they do is those heavy metals would rather bond to those as opposed to your cells. And so if we can get them to bond to something else, then your body can get rid of them just like it gets rid of all the other ways. And so, another thing I can pronounce. There's actually the British Antil list, maybe. This was actually usually injected into the muscle to trap heavy metals, and then after then it can be eliminated through your body through your urine. And so it is not water soluble, so that's why they can't. That's why you can't eat it or drink it. It had to be injected directly into the muscle. But basically, this was actually used to treat arsenic poisoning in World War II when we used mustard gas, because mustard gas actually contains arsenic. And so the mustard gas is not what would cause all the harm to the soldiers. It was the exposure to arsenic and all the effects that would cause after the effect. Because we just said the arsenic will block your proteins in your cells. It'll make your proteins not work like they're supposed to. And so if your army or whatever was exposed to mustard gas, if we had like something that could counteract it, kind of like an antidote, it wouldn't be as damaging to your force. There's also the bad thing about poisons is this whole idea of chemical warfare, and it is probably one of the scariest things. It's one thing to be shot or blew up or bombs or whatever, because there's at least some warning. But when it comes to chemical warfare, it kills everything and everyone that's being exposed to it. And so it's very scary, it's very dangerous. And so there's actually been lots of different peace treaties trying to outlaw the use of chemical warfare. There was one in the 1900s, or actually there was one in 1899 and then 1907 that was signed, but various countries broke it. And so there's actually another one which we'll talk about, the Geneva Protocol. But first of all, chemical warfare there's several different types. The first type we're going to talk about is a choking agent, and basically this controls your ability to breathe. And so this would be like your tear gas or chlorine gas or phosphine gas. Tear gas is not fatal, so it'll affect you. It'll cause you to not be able to see. It'll affect your ability to breathe. It'll make you cough. It'll make you choke, but it's not going to kill you. And so a lot of people thought that countries like Germany and I can't remember the other one, maybe Russia, they used tear gas, and so everybody thought that they broke this original treaty from 1907, but since tear gas is not fatal, they didn't think they were breaking the treaty. And so, however, phosphine gas, it is fatal. Chlorine gas and phosphine gas is very fatal. So some of the retaliants to Germany and to Russia used other weapons of warfare, which is a direct break of that treaty. So that treaty was basically null and void. And so basically, chlorine and phosphine, what they do is they irritate your lungs to such a degree that your lungs will start to fill with water to try to neutralize, because it's basically kind of creating an acidic boundary, and so it's creating water. And so basically, as your lungs fill with water, you're basically going to drown, even though you're not in water. Your body, because your body's 70% water. And so basically, your body is taking all the water from your cells and your blood and fishing it into your lungs, trying to fix that problem. But in the process, if your lungs are filling with water, you're not going to be able to breathe, and so basically you're drowning in your own fluids. Phosphine, not only does it cause this process of drowning you, but it also interferes with the lungs' ability to absorb oxygen. So not only are you drowning, but you can't absorb oxygen, so it's almost like a double whammy. Another type of chemical warfare is blister agents. And these are compounds that can be absorbed through your skin. So with tear gas and chlorine gas and phosphine gas, they could wear the respirators, right? And basically it has a carbon filter. It filters out all those dangerous things so you're not actually breathing them in. Problem solved. Well, we need something. They started to come up with things that could get away from that, because the whole point of chemical warfare is to damage the armies that are coming against you. And so we came up with blister agents, and these they can just be absorbed through your skin. So in order to protect yourself from there, you need to be in a rubber suit, and so that's not as easy to obtain as opposed to a gas mask. And so one of these types is mustard gas. Mustard gas can actually react with the DNA, which then kills your cells. And then once your cells are dying, it causes them to release hydrochloric acid, which is very damaging, which can then cause giant blisters on your skin. So that's why in World War II, a lot of the armies would come home with giant blisters on their skin. If you're exposed to enough of it, it can kill you. But honestly, most of your skin's going to be covered, and so the parts of your skin that aren't covered you're just going to be in a lot of pain. These are mainly sulfur mustards, which means that they had a sulfur compound in there somewhere along the way. Nitrogen mustards, however, can actually be used in low doses to treat skin cancer. So not all mustard gas is harmful. Some of it we can actually use for the good. Another type of chemical warfare is nerve gases. These can be absorbed through your skin, and basically what these do is these destroy your neurotransmitters. And there are lots and lots of different kinds, but there's 3 that our government is well versed at. I'm not going to say we actually use them because I don't know. I'm not even pretend to know. But there's Sabun, Saran, and Suman. And basically what these do is as your muscles work, your brain sends the signal to your muscles to contract, and then it sends another muscle to do the opposite, right? And so basically what happens is nerve gases it causes your muscles to contract, but it never releases it. And so basically your brain just keeps firing and firing and firing to your muscles to contract. And so basically it overstimulates the muscles, which if you overstimulate the wrong muscle, can cause heart attacks. Usually it causes respiratory issues with your lungs. And there is an antidote, atropine, which you guys have probably heard of before. And what they used to do is they actually, in the gas masks, they would put a syringe of atropine in it. So if anybody came into contact with nerve gas, they could give themselves an antidote really quick. So that way, hopefully, they wouldn't die out there if they could get the antidote in their system fast enough. But the bad part about nerve gas is you have to get the antidote really fast. If you wait too long, then the damage has already been done. This led us to the Geneva Protocol, which basically it was a treaty that banned both chemical and biological agents from warfare. So basically it says we can use guns, we can use bombs, but we're not going to use any chemicals. This came around in 1925, but the Senate did not officially sign it until 1972, just because there was lots of clauses in there that they didn't 100% agree with. And so, Agent Orange was technically part of the treaty, and we used it in Vietnam. And so it wasn't until we started using Agent Orange and some of these other chemicals that we saw the importance of this treaty. And basically our motto is we're not going to use chemical warfare on someone else unless they use it on us first. And then in 1993, the U.S., Russia, and 186 other countries agreed to eliminate all chemical weapons. And they said that this would cost about $2 million, and it would take 10 years. Well, it's been 10 years, and now we're thinking it's going to cost more like $30 million and cost 30 years. Take 30 years. We have gotten rid of about 70% of our chemicals, and I think Russia's only gotten rid of 42%. So, of course, there's some political issues there, I'm sure. Homework, really short, page 388, numbers 1 through 9. So, don't forget to look at your review sheet this weekend, and I strongly suggest you do your review sheet. It'll help you on your test, and I'll see you on Tuesday.